conditional probability and independence. What does independence tell me? Question number 67 says 8 the hard way. Maribel is playing the board game 8 the hard way with her friends. Each player rolls 2 dice or on his or her turn and moves according to the sum of the dice. However, if a player rolls 2 4s, called 8 the hard way, the player instantly wins the round and a new round is started. Delaney steps into the kitchen to get snacks when she hears Maribel shout, "Woohoo, I got an 8. Delaney knows Maribel rolled a sum of 8. With your team, help Delaney investigate the probability that Maribel rolled 2 4s and won the round of play. In other words, calculate the conditional probability that Maribel rolled 2 4s, given that you know she rolled a sum of 8. So for part A, the first thing that they wanted you to do was to make a diagram to represent all of the possible sums of numbers when rolling 2 dice. You can use that E tool to fill in your chart. So if you roll a 1 and a 1, you should get a 2. If you roll a 2 and a 2, you should get a 4. If you roll a 3 and a 3, you should get a 6. So you're going to fill this whole chart in. Use the E tool to help you if you want. Okay? Part B says, since you know that Maribel rolled a sum of 8, you do not need to consider all of the outcomes in the sample space. You only need to consider the outcomes with a sum of 8. In your diagram, highlight all of the ways a sum of 8 can be rolled. How many different ways can a sum of 8 be rolled? So you're going to count how many. Okay. Part C says you are interested in only 8 the hard way. How many different ways can 2 4s be rolled? Just one. There's only one way that you can get a 4 and a 4, right? But what is, part D, but what is the probability of the event, 8 the hard way, given that you know Maribel rolled a sum of 8. So you should have gotten 5 total, and there's only one way to get it the hard way. Part C says, is that an E? E. Becca rolls high, meaning that she rolls a sum of 9 or more. What is the conditional probability that her roll is also an odd number? Okay? So now we're going to switch it up just slightly. So any of the boxes that are 9 or more, you're going to count up how many total are 9 or more. So 9, 10, 11, or 12, right? Because 12 is the highest you can get. You should get 10. You guys have 10? Yeah? Of those 10, how many of them are odd? So they would have to be 9 or 11, right? 9, 10, 11, yeah. Did you guys get 6? Okay. Anybody still writing? Flip over to the top of page 13. Question number 68 says, at Einstein High School, data on members of the student council was collected. This type of table is called a two-way table. Oh, we didn't highlight that. And is often used to organize information and calculate probabilities. What is the probability of a student being on student council at EHS? Okay, so we need to take the number that are on student council. So I got 6 people on student council here and 34 people on student council here. This whole row is on student council, so that adds up to 40. Then we need to take it out of the total. So the total in all four boxes is 240. And you can turn a fraction into a decimal by dividing 40 by 240. You'll get approximately or roughly 0.1667. They want us to shade the cells with students who eat in the cafeteria. So these students eat in the cafeteria. What is the conditional probability of a student being on student council given what you know the student eats at the cafeteria? Okay, so in this column, we have 6 students that are on student council and eat in the cafeteria. We have 6 of them, but there's 36 total in that column. Okay, so 6 divided by 36 is again the same decimal we got in problem A. Question C says 2 events, A and B, are independent. If knowing that event B occurred does not change the probability of event A occurring, that is, 2 events, A and B, are independent if the probability of A given B is equal to the probability of A. Are the events on student council and eats in the cafeteria independent? Why or why not? Yes, one event does not rely on the other. So if a student is on student council, they could eat in the cafeteria or not eat in the cafeteria. They're independent events. It doesn't matter one or the other. Okay? So we consider them independent. Part D says 2 events are mutually exclusive, or what they call disjoint, if they cannot both occur at the same time. That is, 2 events are mutually exclusive. Are the events on student council and eats in the cafeteria mutually exclusive? Why or why not? The answer is no, because 6 students do both of the events. They're on student council and they eat in the cafeteria. Okay? Any questions on problem 68? Okay. Question 69 says the following data was collected about students in Mr. Rexinger's high school statistics class. We've got students wearing jeans, students not wearing jeans. We've got students with long hair and students that do not have long hair. Okay? Question A says, Mr. Rexinger is playing a game with his students. He randomly chooses a mystery student from his class roster. If a player guesses the hair length of the mystery student correctly, the player gets an early lunch pass. Sweet. Madeline is the next player. To have the greatest chance of winning an early lunch pass, should she guess that the student has long hair? So 18 out of 32. So she should say no. There is a greater probability the student does not have long hair. So just based on chances, she should say no, they don't have long hair, and she's more likely to get an early pass to lunch. Question B says, Mr. Rexinger tells Madeline that the mystery student is wearing jeans. Would you advise Madeline to change her guess? Well, yes, you should advise her to change her guess, because now she should guess that the student has long hair, because 5 out of 12 is 41% versus the 57% we had up here. Okay? Any questions on A or B? No? Anybody still writing? Okay, let me give you guys a chance to catch up. The next page, page 14, is question 69 continued. It says, in a previous course, you may have studied the association of 2 numerical variables by analyzing scatterplot and least square regression lines. Association between categorical events like having long hair or wearing jeans are determined by independence. If two events are independent, then they are not associated. Are the events not having long hair and wearing jeans associated for the students in Mr. Rexinger's class today? Explain the independent relationship using the probability of A given B. So you're going to say they are not independent, they are associated at this point. And then are the events, meaning not having long hair and wearing jeans, mutually exclusive? You're going to say no, there are 5 students who do not have long hair and they are wearing jeans. All right, the last thing in today's lesson is question number 70. It says, the Digital Technical Institute, the following data was collected. So you have members of the Honor Society and not members of the Honor Society. And then you have students that are on academic probation and not on academic probation. In your groups of 4, you're going to answer questions A and B. A says, are the events of academic probation and being a member of Honor Society associated? And then question B, are the events on academic probation and member of the Honor Society mutually exclusive at this institute? How many outcomes are in the intersection of the 2 events? Then you're going to do the learning log down at the bottom, which just says, explain what it means for 2 events to be associated. Think of a new situation. You could make one up of kids in this classroom because there's a lot of people wearing certain colors today. Think of a new situation and 2 events that are associated mathematically and explain the difference between mutually exclusive and independent events in your own words.